Thank you all for coming to the 7.5 release for the Gradle build tool. We're going to start off with introduction, overall, how many commits and whatnot, and then each team is going to kind of take charge and do a presentation on their contributions to this release. So as far as the overall picture of Gradle 7.5, this was definitely a huge endeavor by the entire team with 5 release candidates, if I recall, and it's the first minor release since February. So it's an amazing thing that we're out with it. There was 2,443 commits with 87 issues being fixed and a whole bunch of files, insertions, and deletion. And one of the really cool things in my mind, because I'm the developer advocate, is we had 35 external contributors with this release, which is just amazing. Compared to the last time, this is pretty much double the amount of external contributors. And we're going to go into these more detail as the team goes on, but some of the features is it has now support for Java 18. We have Groovy 4 for building with. We have a very responsive continuous build. And then we have an improved diagnostics for that dependency resolution, which the team will get into. And there's so many more features with this release that I'm excited to see what they've presented. Each team has a set of slides, and some of it is going to be recorded, but most of it is live, and there's a few demos in there as well, so you can kind of see what they've been working on and doing. Okay, any overarching questions before we break into the teams? Okay, with that in mind, the first team up is going to be Rodrigo.
So yeah, thanks everyone for attending. The first contribution of the configuration cache team I'd like to share with you. This was implemented by Paul's very capable hands as his farewell gift to the configuration cache team. Thanks, Paul. So this feature allows dependency resolution results to be used as task inputs, right? So we commonly use, right, dependency resolution as task inputs when we think about like simple file collections, right? But more rich models of like the graphs and all that, tasks could implement and get those results, right? But not as inputs and not in a configuration cache friendly way. If they could, it would become cumbersome, right? So now with this release, we have proper APIs that are supported by the configuration cache. So the first one is the ability, right, to just get a fully resolved component graph, right, as an input to a task. So you can navigate the edges, see the dependencies, which components were selected, for which reason, and all that. And we also introduced the ability to get a list of all the component artifact identifiers, right? There'll be like a flat list of everything, but also with metadata, right? So you can see why that a variant was selected, for instance, and things like that. There's a full sample available, but just for to prove that everything works and is configuration cache friendly, I just want to run this demo for you, so you see how simple it is. So first we can see a task, right, that uses the API just to navigate this resolve dependency results, just a simple dump. It can be configured in a build script like so, right, just setting that path. And it just works, right? We can store with the configuration cache and we can load with the configuration cache, and the result is the same, right? And here we are seeing the same, but for the artifacts, right? For the list of artifact identifiers, just a flat list, and here just the display name. It's configured a bit more in a bit more involved way, because we just want the identifiers, not everything, right? So we do this map over, but it's also configuration cache friendly, as you can see. So for the next configuration cache improvement, we tackled the ability to run external processes in a configuration cache friendly way, right? Previously, external processes were allowed, like you could use the exec, Java exec APIs, but the output of such process were simply ignored. And you can imagine that would be a problem, right? If the output of a process actually is used to affect configuration in any way. Here in this sample, I'm just doing like a very synthetic example where I set the property of some task, right, to be the result of this Git output execution, right? And we can see that the results are not as expected, right? Or they might be if you know what's going on behind the scenes, I guess. So here I'm just using this exact task that I showed to show like the Git revision, right? And then we just change the revision with an empty commit, and we can see that the task, even though the revision was changed, right, won't be able to react to that change because the revision was captured at configuration time. So now the configuration cache doesn't match, right, the reality. So with 7.5, we introduce this new provider-based API implemented by, if I recall correctly, the capable hands of Mike. So with this, now we provide, right, no pun intended, new APIs that allow you to get providers, right, for like the text output or the bytes output of a process. And just to show, right, so this is a syntactic example. Again, I just access, right, I made the example access the output of the process at configuration time. And again, just configure the task with that value, right? So we just got the value from the provider. And when we do that, right, we can see that in the configuration cache report, this is just a small snippet of the configuration cache report, we can see there's a new output that is identified now. So we see the output of external process Git by this plugin. And with that output now detected, input, the output of the process being the build configuration input now detected, things go as expected. Right? So again, the same thing, we get a revision, right? I'm gonna run the task. It's gonna be stored to the cache, right? It's being stored. And we're gonna change the revision again. And the second time, the task will execute with the right contents. Except, right, that we had to store this configuration cache entry again, even though, right, the only thing that changed was this external output of the process. And we have to do that because we access the process output at configuration time, right? So there's a better way, right? And the better way, as you probably imagine, is not to access the output at configuration time if you can, and simply wire, right, the output of a process as an input to the task. And when you do that, you see that that process output is no longer a configuration cache input, right? For some reason, there another system property here was considered input. I don't know why, but you don't have to care about that. Oops, sorry. And let's run that one. So you don't need to take my word for it. And again, the same process, right? We just we're going to change the revision. And this time we're going to see the better behavior, which is to actually reuse the cache after the Git revision has changed. Yeah, and you can see configuration cache entry was reused, which is great. So for more complex scenarios, right, maybe you have to call like lots of different processes. You have to involve different inputs from the environment, right? We have the value source API, which is supposed to represent these external contributions to the configuration cache. And starting with 7.5, inputs that are used in the context of a value source will no longer be detected as configuration cache inputs. Only the final result of the value source will be checked. So the value source can use many processes. Next time we need to run tasks from the configuration cache will rerun the value source to make sure the values still match. If they do, then everything goes as usual, right? You're gonna have to take my word for this one. I just wanted to show that the report will include, right? When you have a value source, you can see that we see a value from a custom source. We can see the provenance of that source. And so that's it for external processes. So now talk about another type of input, right, that went unnoticed, right, until recently. So let's say configuration logic, like build logic, just uses, right, Java I/O APIs to access files and whatnot. So before 7.5, right, those would go unnoticed. In 7.5, we actually instrument and detect a few APIs. We don't detect every type of access. This will still come once we implement a new solution to how we instrument, right, the execution of the configuration phase. But for now, you start seeing more and more of those APIs being covered and then providing inputs, right, and then appearing in the report, as you can see here, right? So again, if the file is changed, the configuration phase will rerun as expected. On the same topic, right, of reading the environment, we also improved some scenarios. So in 7.4, we started detecting some of these inputs automatically, like when you use system get env, or all the ways you can access system properties in Java, right? Like integer value of and all those APIs, right? Unfortunately, some patterns can cause like just excessive or variable accessible input capture, right? So we actually had this scenario recently in our own build, right, where we do something with the system get env and we end up capturing every single environment variable, right, that was set at the time. And that will, of course, cause lots of cache misses because, yeah, environment variable system properties changing. With 7.5, we introduced this new API, environment variables prefix by and system properties prefix by. So this common pattern can now be used in a very efficient way, right? So now only those system properties or environment variables that actually match will be considered inputs to the configuration cache. And as I mentioned before, the value source gain also this special power that it can read the environment at will and nothing will be considered an input, only the final result produced by the value source. Oops, I think I missed something. Yeah, so we also had a few new improvements to plugins and tasks. So the Kotlin DSL plugin, which is useful, right, for people writing Gradle plugins using Kotlin, using like precompiled script plugins and things like that. So now that plugin is configuration cache compatible. And since we also implemented this dependency resolution results as task inputs, some of the tasks that actually use dependency resolution results to generate reports like dependency insight, outgoing variants, and resolvable configurations were improved. Yeah, thanks again, Paul. So we introduced a new stable configuration cache feature flag because after we made this input detection and some of the strictness or stricter validation that we apply to the configuration phase when the configuration cache is enabled. Yeah, some users complained, right, because it's actually a significant effort to migrate, still is to migrate a complex build to the configuration cache. So we decided to introduce this flag. So the more, disruptive validations are now behind that flag, right? So for instance, using external process via this legacy, let me call that API legacy, Java exec and exec APIs, right? If you enable that stable configuration flag in your build, this is what you would see if you wrote code like that one that I showed you on the first slide for the external process, right? And this is actually an error. You would fail the configuration cache, you would fail the build and all that. And I think that's all I had for you today. Any questions? Okay, so thanks everyone. Amanda, back to you.
Okay, I think next up is our core team, and so that would be Sterling. Are you ready, Sterling?
Yeah. You want to stop sharing, Rodrigo?
I do. Yeah.
All right. Does that work for everybody? Everybody can see that?
Looks good.
All right, awesome. You're gonna get to hear from more than just me. So I have the most boring feature of 7.5, which is some internal dependency, not internal, but some new API for dependency resolution, dependency management. So we have this problem where when we are trying to pick what kind of variant we want from a dependency, we kind of rank each variant based on its attributes. And in some cases, you can actually have two variants that that rank identically. They have different sets of compatible attributes. And so here's an example here of a dependency with API as classes and API as a jar, runtime as classes, runtime as a jar. If you had to choose between API as a jar and runtime as classes, which is more preferable? Like if both of those are compatible. And so with the way it worked before, there was no way of Gradle choosing, and so Gradle would just blow up saying, I don't know, pick one for me. So we added an API that allows ecosystems to define what order to consider the attributes in. And so basically it means that attributes that are higher in precedence, if they disambiguate the result, they win. And then otherwise it goes through normal disambiguation. So this is set for the Java plugin right now. This is what the API looks like. And this is underpinning some of the changes we're making for making artifact views behave in a different way, which didn't make it into 7.5, but hopefully in 7.6, or must be in 7.6. We'll see. All right, I think next one up is Justin. You ready to go?
Yes. Hey there. So Sterling had the most boring features, the most boring bug fix. For test workers in the past, we were opening modules. Since we had code that were running in test workers that required to interacting with some JDK internals. But in some cases, if you wrote tests that would touch JDK internals and you didn't open these modules in your production code, you could actually have unreliable tests. So what we did here is we removed these openings, these module openings, so then the tests are more reliable, and you can be sure that if you are touching JDK internals in your tests, that it'll actually fail, which is what it should have done all along. So we still open one of these modules when using Project Builder, since that requires using JDK internals, but everywhere else we do not open the modules, which is good. So that's all I got here.
All right. Tom.
Hi everyone. So a new feature that was added is a new show version flag. So the purpose of this flag is to print the version info that was currently printable with the -- version flag, but not immediately exit Gradle. So in a single Gradle invocation, you can see all that version info and then run your tasks to capture the whole thing in the log. This could be useful in CI environments where you don't want to be running Gradle more than once. So next slide, I'll show you what it looks like. So there's an example of the output. You're running help -- show version. So you've got the familiar version info up top, and then it goes into actually running the help task. If you use -- version here, and use that on your command line, it would just print the top block with the version info and then exit. It would ignore the task that you had. Next slide. So we improved the outgoing variance report. This is an existing report that's used to investigate unexpected dependency resolution outcomes. So you have a scenario where you have a producer project and a consumer project, and you want to know why the consumer project is picking a certain variant of the producer project. Consumer project is picking the producer. So you run this report on the producer side, and it's meant to be the easiest way to view everything available for selection, especially if your project doesn't have Gradle model metadata available. Even if it does, that's lengthy JSON, not meant to be very human readable, and it doesn't list any secondary variants. So if in certain scenarios, you have an included build here, those could be the variants you care about. So you would run this report and you could see them. So this lists the inputs that are used to the dependency resolution process when it's figuring out what variant to select. So it lists all the attributes on those variants. Some of these attributes are not going to be explicit anywhere in your build scripts because they're added by plugins. So we did some work to improve this report, improve the output format, clean it up a little bit, add some additional information to it. One thing we add that's related to this report is that you can now add descriptions to your secondary variants. Before this wasn't allowed. Now, if you want to describe the purpose, you can use something other than the name and have it appear in this report. The report uses the rich console output. Each color actually has certain semantics. They mean this is a header, this is a description, this is an identifier. And now the report output uses those colors more appropriately. The output is now sorted, so it's easy to find stuff. The classifiers are now printed if they're available. There were existing flags for all and for printing just a certain variant, and we changed the behavior of those to be a little clearer. Previously, listing just variant, the message was a little confusing if the variant you were asking about was a legacy variant. Legacy variants are both consumable and resolvable. You really should be either one or the other, but there's legacy configurations that are both, and they could be hidden, or it couldn't be clear that you weren't finding one because it's legacy. Now those flags will give you sensible messages that'll point you right to, hey, I searched for absolutely everything, including legacies, and I couldn't find this, or I'm displaying just non-legacies. It'll make sense in the output. I can go to the next slide. We'll see an example of the new output. So here is a producer project that is producing just a couple custom configurations. It's not applying a typical plugin, but you can see the output format here. Maybe not all that different at first glance from the existing format, but it is printing things that wouldn't be there, if they're relevant to that output. Next slide, please. So this is a new report that we added called the Resolvable Configurations Report. This is the complement of that outgoing variance. So in that producer consumer scenario, this is a report you would run on the consumer side, and it would give you similar information. What attributes are on the configurations that I'm trying to resolve. So by running these two reports together in a producer consumer scenario, you can get to the bottom of why was a particular variant selected and others not selected. Why am I not getting what I thought I was going to get from the producer? So this has the same sort of filtering with legacy configurations. This also has a recursive option so that it'll display configurations which are extended transitively, which can be useful on the consumer side. There was a lot of behind the scenes work when this report was added to refactor the code that is now used for both of these reports, so that it separates the different steps in the process of gathering the data and then formatting it. This makes it a lot easier for us to add additional formatting as that becomes needed. This has already been proven out. Sterling mentioned earlier that we now have, disambiguation rule precedence on attributes. Adding that to this report, which didn't make it into 7.5, but it'll make it in 7.6, was a piece of cake. And before that code was not too easy to modify. So go back to the next slide. We'll have a example of the output. So this is the typical output you would see with a Java plugin plus a custom configuration that's just requesting a single attribute. So you can see this is the mirror image of outgoing variants. It's looking at, here's the configurations on my consumer project that I can resolve, and here's the attributes they will be requesting. At the bottom, there's also sections for compatibility rules and disambiguation rules. There's no real way yet to summarize, what those rules are going to do, but we can at least clue you in that these rules exist. They affect these attributes. So if you're seeing, your output in these two reports, and you're seeing, hey, all these attributes don't match. Why was this variant selected? You will at least get clued into, well, there's a compatibility or disambiguation rule in play here affecting those attributes, and you'll know to investigate further. And next slide. And this is just a grab bag of other interesting changes that you might want to look into further. With this release, the JavaDoc task options set on it previously weren't included in up-to-date. So if you changed some options and expected differently formatted JavaDoc, you wouldn't get it because the task would just say, I don't need to rerun. Now it does. Configurations using lazy and eager attribute values wasn't working right. Now it will properly honor, the last update to those attribute values. Jacoco aggregation and the Kotlin JVM plugins now work nicely together. And non-standard test source can be filtered by containing class. So if you have a, you only want to run a subset of tests, but the tests that you are filtering includes things like arc unit tests, which are use field-based sources. You can filter those by the containing class. So that's now possible.
For 7.5, I added dependency insight report improvements. This is a set of changes to the dependency insight task, which allows you to display variants of certain dependency. For this particular change, I added a all variants flag, which you can use to display every variant of a dependency that can be used in dependency resolution. This can be used to see what attributes needed to add if you want to select a different variant. The report also now uses a table to display these variants, which allows you to more easily compare and contrast which ones are selected or not, and this has some details as you can see here. I've added the word variant to indicate that these are variants, and I've also added these three columns. One of them is just the attribute name. One of them tells you which values are provided by the dependency, so these are the ones that are actually set in, for example, the Gradle metadata. And there's also the requested column, which tells you what the configuration that is resolving this dependency has requested. And there's also some coloring to show the differences between which ones are matched and actually used in resolution, and which ones are just unmatched and we just used it because none of the other ones were a better match. I also added Java 18 support. This is pretty simple. Gradle just now supports running and compiling with Java 18. So if you want to run Gradle with Java 18, you can, and it won't cause any problems. I also merged in a community PR which added additional flags to our GroovyDoc task. These are access to control the level of included doc items specifically. We used to have include private for this, but now this flag controls all levels including package private or protected. There's the include author flag, which controls the inclusion of author paragraphs from the GroovyDoc. There is process scripts, which controls whether or not scripts are included in the outputted GroovyDoc. And there's include main for scripts, which controls whether or not a script's main method, which is implicitly added, is included in the Groovy doc.
All right. So that is all of the core team. One thing we forgot to mention was the show version flag that Tom showed off at the very beginning was a suggestion in a PR, I think, from Leo originally, wasn't it?
Yep.
Yep.
Yes.
Yeah. So thanks for that. All right, back to you, Amanda.
Okay, next is our support team. So I think, Paul, you're leading this one up. Are you ready?
So the first one is a feature that was added to the properties task. The properties task allows you to list all the project properties of project, but often on CI or for keeping track of specific properties, you want to specify only one or a set of properties you want to list. It's pretty simple. You invoke Gradle properties -- property, the name of a property, and you get only this one. Next, this one is a bit larger, so we made some changes to how JVM toolchains are resolved to follow up on the kind of a mess between adopt OpenJDK and Adoptium. So we now check the Adoptium API first when downloading JDKs and fall back to adopt OpenJDK if we cannot find a suitable JDK. Because like one of the services hosting a range of version and the other one another range. So we also added some properties, system properties, so folks can override the base URIs to the services. And anyway, all this should go away soon because we are working on making the resolution of JVM toolchains pluggable. So we will end up removing this from the core. But this will happen later. Some work has been done also to improve how Eclipse see test sources from test fixtures, test suites, and so on. The mechanism in Eclipse to separate source sets is quite rudimentary, and we had to tweak it a bit so that, for example, you don't see test code available in your production code. So this is the fix. And this works both for folks still using the Eclipse task to generate Eclipse files or folks using Spreadsheet. And it's not really part of the Gradle 7.5 release because it's not in the distribution, but it happened at roughly the same time. We published the plugin publish plugin, which is used to publish Gradle plugins to the plugin portal, version 1.0, and it's a lot of changes. It now relies only on and exclusively on the Java Gradle plugin and the Maven publish plugin. The configuration has been tightened. The DSL is smaller. It should be less confusing for users. And there is now only one way to configure publication. Before there were like as many ways as you could imagine, basically. And it has also new features to integrate with signing and shadow, which are very frequent use cases for plugin authors, and now this is integrated. Along the way, we made some breaking changes, like we only support Gradle for the 10 and up, but 3.something before. And we removed some DSL configuration that were conflicting with the changes. And just a bag of miscellaneous things we did during this release. So we upgraded some components, such in checkstyle and ScalaSync. And we made some nice quality of life improvements. better default answers, built-in questions, actually better exit code handling by all the generated script on Windows. So that's for the Gradle wrapper, but also for the scripts generated by the application plugin. We fixed the support for constraints on project dependencies that was broken for a long while. And in the goal of having saner default in Gradle, we added a warning if the root project name is not set. We made some improvements to documentation and merged quite a bunch of community pull requests with mostly bug fixes, but two interesting features. One is to add the GDKs downloaded by IDEA to the detection system, so we can reuse them directly. And adding a new -- groups option to the tasks task, so you can list tasks from a set of groups in one invocation. And that will be it for me. Any questions? Yeah, I see one question about the plugin publish plugin being compatible with the configuration cache. So it isn't yet. And the Maven publish that it relies on is not compatible yet in 7.5 Asia. So a little bit more time. Okay, to you, Amanda.
Okay, next and our last team is the execution team. So Stefan, if you're ready.
Yep. Hello from the execution team. So I'm gonna present something, and then Anja will also present a little bit. So can you see the slide? Yep. Awesome. So the flagship feature is the more responsive continuous build. So continuous build is the feature of Gradle that automatically re-executes the build whenever the inputs change. So you would start a build with -t, and for example, like running something or running a server, and then we would change any source file, and then it would rerun the build and redeploy the server and do some auto reload when your plugin supports that. The problem we had with that we have been using internal APIs so on macOS, the JDK APIs only support polling, which is not like the best API to detect file system changes. And we used those in this feature from the start. And the problem is with JDK 9, we were not able to set the polling intervals lower, so the actual polling interval was 10 seconds, which is like you can need to wait up to 10 seconds to show change. On the other hand, we also implemented file system watching, which uses our native integration to watch the file system. And the idea was to replace the old infrastructure by the new one and throw it away. This was not completely simple, but let's first look at the difference between the old and the new stuff. So I have a Mac and I have a new Java version. So let's see what happens here. So I have a simple like project using Java, just using Gradle init. So let's start with 7.4.1. I start the build with continuous build, and now I do some changes here. I saved, and now we're waiting. Still waiting. Oh, now something happened. Let's do another change. And we saved, right? Yeah, so it's not super responsive. Okay, let's stop this build, and now let's try the same stuff with Gradle 7.5. So we're waiting for changes. We do the change, save, and here we go. Right, so it's basically instant now. Yep. That was the live demo, so you actually see the difference. And this was pretty problematic for tools like Micronaut, right, which have like a very oops, which already are very fast, say under 1 second startup time, right? And then you wait like 10 seconds for Gradle to redeploy your code, which is not very optimal. Yeah. So next up is Antje. I'm gonna do this slideshow, and Antje, you can unmute yourself and talk.
Okay. So yeah, code quality tools got some improvements with this release. So first to mention is check style. So check style tasks now use Java toolchains. That means that you can set the Java version you want to run check style with. Now, a nice feature is also that for Java project, if you set a Java version on the Java extension, check style will automatically pick it up. Of course, you can then override it if you want. Yeah, and for all other projects, check style will use Java default Java version that's used by the daemon if you don't set anything else. And then another thing, it's kind of related or not, but check style tasks now use worker API, and with that, check style now run in parallel within a project for every source set. So with that, you might see some performance improvements, especially if you have a lot of sources. Now, if you have just main and test source set, you might not see much of improvement, but if you also have like integration tests, functional tests, stuff like that, there might be some improvements. For that feature, we also got a nice feedback from Elasticsearch. Down below, you can see benchmark for Elasticsearch project. And with 7.5 and check style changes, they got some nice improvement. They saw also like 40% improvement in their build time due to better parallelization. Okay, that's about check style. Next thing is PMD improvements. So this was contributed from the community, so that's nice. So option to run PMD with multiple threads was added in this release. So now you can set how many threads PMD will use. The tool will use. Now this is not related to worker API, but this property is just passed to PMD tool, and PMD will run with the number of threads you will set. And with that, you might see also some improvements if you have a big source set with a lot of file in it. For example, for some monolithic applications, you might see better results here. Okay, that's it from our side.
All right. Any questions for the last part, or for any part, it seems?
I have maybe a comment with regards to the threads. We also have those for forks or something. And would it make sense to have a thread property where you can say use all CPU cores or half of the CPU cores or something like that? Because yeah, we end up implementing it all over the place again. So maybe the utility property for that would make sense.
Yeah, I think like managing threads and number of workers and memory, that's a sore point we don't really have a good answer for, because like it's not, I guess there's two parts, right? There's like making it easier to set a given property relative to like what the machine has, right? So you don't have to just say 2, 4, 6, 8, whatever. That would be helpful, but doesn't solve the other side of the problem of you don't want to set, you don't want to give every PMD task 4 threads, because they might run, we might run 10 of them in parallel, and what does that mean? So yeah, maybe I'm not, I think it's a good idea. Just how do we do it in a way that doesn't make it worse? I'm not sure.
Okay, any other questions or comments? Okay, well, thank you everyone for coming and hearing about the 7.5 release. It was really great to kind of see this come together and hear everyone's kind of contributions and how it made a really awesome product. So thank you for coming, and I'll push the release or the recording of this out, and maybe I'll edit a bit and make it for a wider consumption. Thank you, everyone. Have a good rest of your
Thank
day.
you.